All right, this is Chapter 9, Lesson 3. I'll be doing the guided practice off page 736. Today we're talking about compound events. Well, compound events means that two or more simple events have to take place in what we would call one experiment. One experiment has two or more simple events. So we'll do a couple here off the guided practice. First one says a coin is tossed twice. Okay, so that means we're tossing a coin not once, but twice. So one toss of the coin is either going to give us a heads or a tails. Okay, so this is the first simple event. Then we have the second simple event. Even if I got heads, I flip it again. Now I either have a heads and a heads, or I have a heads and a tails. Because once again, on this flip, I'm either going to get a heads or a tails. Whether I got a tail, even if I got a tail on the first flip, I still could get, with a tail on the first flip, I could still get a heads or a tails. So now we have these four possible outcomes. This is what is called your sample space. That's the list of all the possible outcomes. I could get a heads heads, a heads tails, a tails heads, or a tails tails. Those are my four sample spaces. Okay. Second one, a pair of brown or black sandals in sizes 7, 8, or 9. So once again, first I'm going to choose whether I'm going to get brown or black. Then, sometimes I do this to abbreviate, I'm either going to get brown 7s, brown 8s, or brown 9s. Or I'm going to get black 7s, black 8s, or black 9s. So if I look at this, this isn't just a 7, this is a brown 7, a brown 8, a brown 9. That's not just an 8, that's a black 8. So what do I have here? I have 6 possible outcomes in my sample space. Brown 7, brown 8, brown 9, black 7, black 8, black 9. By the way, this is called a tree diagram that we're doing. Every time you make one of these little arrow things to give you your choices, you're saying this is a simple event that I'm taking, or a simple probability that I'm dealing with right here. Making one choice between two items, two choices, making a choice between 3 items, and if you notice, 2 times 3 gets you how many in the sample space? 6. In the same way that 2 items and 2 items, 2 times 2 is 4 possible outcomes. It's called the counting principle, by the way. Number of choices times number of choices gets you the total number of outcomes. All right, let's try one more. Number 3 says, Gerardo spins a spinner with 4 equal sections labeled A, B, C, and D. He spins it twice. There's why we're dealing with a compound event. He's not spinning it once, spinning it twice. If A is spun at least once, Gerardo wins. So anytime that he has an A or 2 A's, 1 or more A's, right, he's going to win. Otherwise, Odell wins. Use a list to find the probability that Odell wins. All right, so this is called an organized list. You can do this with tree diagram as well, but I'm going to make an organized list. Let's say he got A on the first spin. He could get A, he could get A, B, he could get A, C, he could get A, D, because he's spinning it twice. What if we got B? Well, he could get B, A, B, 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 C, B, D. If you got C on the first spin, he could get C, A, C, B, C, 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 D. If you got D on the first spin, you get D, A, D, B, D, C, D, D. Those are all the possible outcomes. By the way, once again, I'll go back to that counting principle idea. Number of choices on the first one was 4. Number of choices on the second one is 4. So if you multiply those together, we should get 16 different outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different outcomes. So now let's go back to it. Which ones of these are winners for who? We want to know when Odell wins. So let me review that. If A is spun at least once, Gerardo wins. Otherwise, Odell wins. So I'm going to mark out all the ones that Gerardo wins. There's at least an A, there's at least an A, there's at least an A, at least an A, at least an A, at least an A, at least an A. So now we have all the winners for Odell. None of these have at least one A in them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 winners out of 16. So the probability that Odell wins is 9/16. And if you divide 9 by 16, you'll get he has a 56.25% chance, or 0.5625 as a decimal. So as a fraction, as a percent, or as a decimal, we can find out Odell's chances of winning. Could you figure out Gerardo's chances of winning? Well, Gerardo's chances of winning, we could go back and write the fraction from the ones I marked out. He would have had 1, 2, 3, 4, 5, 6, 7 chances out of 16, which you might realize is the complement that we talked about a couple lessons ago. 7/16 plus 9/16 is 16/16. That's all of it, right? So you would know that if he had a 56.25% chance of winning, then that must mean he has a 43.75% chance of winning, or 0.4375 as a decimal. So we can write that as all. That's a complement, because either Gerardo wins or Odell wins. They didn't give us any other options there.